this activity deals with correlation and linear regression. And I gave these links to these sites when I was kind of looking around. And this first site, I say it gives a really good overview of regression. And it's from the National Library of Medicine, National Institutes of Health. And they talk about linear regression analysis, the background, the methods, results, conclusions, pitfalls. They talk about the correlation coefficient and interpretation. We are only doing linear regression, although they talk about, what if your dots don't follow a linear pattern. So this is just kind of neat. They talk about some of the studies, some of the confounding variables. There's the confounder, selecting your variables, and so on. So this is kind of a neat page, and then at the bottom they have some references. And I clicked on this one. They talk about association or causation. I kind of went on a few links, and I got to the Dahl and Hill's publication, and notice this is from 1964. This is kind of one of the first articles where they first showed the relationship between cigarettes and lung cancer, smoking and lung cancer. And you can see that, they did use scatter plot, linear regression when they did this study. So number of cigarettes smoked per day and annual death rate per 1,000 men. The reason they only did men is they used doctors in the study, and in 1964, doctors were primarily men. But the other thing you can see in the study is they talk about significant differences, and then p less than 0.001. That's our p-value that we talk about in class. And then not significant, p greater than 0.05, so it was greater than the level of significance, which means there they would fail to reject the null. Here they would reject the null. So you can sort of see that these things really are used when they do studies, and have been for a while. So this is just kind of interesting, and to see this really seems to follow a linear pattern. The more cigarettes you smoke per day, the higher the incidence of death due to lung cancer. We are going to do a less serious example, and this website I also gave on the Excel file that I posted. It's called Spurious Correlations, and it's just kind of funny. Some of the things that they can prove appear to be correlated to one another, but there's no causation there. So they have these graphs, and you can see that the trends seem about the same. This one is kind of a morbid one, but then there are some funnier ones. Number of people who drowned by falling into a pool, and films Nicolas Cage appeared in, and you can see sort of a similar pattern to the graphs. Now we're going to do it differently. They have two different graphs. We're just going to do one graph. We're going to do a scatter plot. They do the drownings by year. That's the red line. So you can see in the little key the swimming pool drownings, that's red. And then the Nicolas Cage films in that year, that's the one in black. And so they did two lines where the x value is either the x value is the year, and the y value is either Nicolas Cage films or swimming pool drownings. I am going to do this one as the example, and I will have you do this one as the graded problem. So you'll do people who drowned after falling after a fishing boat versus marriage rates in Kentucky, and I will do the age of Miss America versus murders by steam, hot vapors, and hot objects. And so the first thing you'll have to do is actually enter the data. And in the practice problem, I already have it entered here. So what you'll do is, and I tell you which one to use as your X value. I say use marriage rates as the X values. So you'll type marriage rates in Kentucky and then put the drowning by falling out of a fishing boat or whatever in the Y. And then you'll just have to enter these data by hand. And so what you'll do is you'll just highlight each of the dots and it tells you the points. So like my first dot, so the age of Miss America was 24, murders by steam 7. So I went to my thing and put my first data point was age of Miss America was 24, murders by steam, etc. 7. And then I did that for each of the points. So I just kind of traced along the graph and then recorded those values in there. So if for some reason this website is not working for you, I will go highlight here. You'll maybe have to pause to see them, but I'll just quickly go over them. You may have to just rewind a couple times. If for some reason you can't get the website to load, here are the points. At first when I was looking at this, I thought, well, that's weird. It looks like they're on the same point. Why is one of them 8.4 and one of them 7? So notice they have the vertical scale for fishing boat deaths over on this side and the Kentucky marriage rate over on this side. So that's why the fishing boats it looks like they're on the same Y value, but the fishing boat is 7 because if you go over this way, you're between 0 and 10. And the Kentucky marriage is 8.4. Yeah, you're between 8 and 9. Okay, so now go back to my page here. And the first thing I want you to do, I think, is just produce, after you get that entered, produce a scatter plot. We'll give it a title, label the axes, make sure we show the regression line and the equation of the regression line. So sometimes if you highlight the headings, it will put those on the graph for you, and sometimes not. Just highlight the whole table, and then I want to insert a chart, scatter plot, and I just want this one for now, just the dots. And then I'm going to go to the quick layout, and I want one that has labels for the X and Y axes, a place for a title, the line on the graph, and the equation, and it looks like that's going to be this one right here. Yep. Okay, and it gave us part of the title, so we don't have to enter all of it. So I'm just going to make this a little bit bigger. We don't need the legends over on this side, so I'm just going to delete that. And just because we have so much empty space in the graph over here, I am going to change the values on the x-axis. Remember, that can sort of make the graph be a little bit misleading, but I just don't want all of this empty space. So let's right click on a value on the x-axis and format axis, and let's make our minimum be 15 instead of 0. And then I think everything else is okay. So I'm just going to hit tab, and then it should change it. Yeah, that's a little better. We could probably even make it 18, I guess. Let's see how it looks if I change it to 18. Okay, let's do that. It just looks nicer. And then we can close this. You can decide on scale for the y, but I don't want to see a ton of empty space in your graph. Okay, so the axis title. My X values are Age of Miss America. I need to type that in here. And then the units are years. And then for the vertical, you know what? I'm going to see if I can just highlight all of this so I don't have to type it all myself. So I do Control C to copy, click on axis title, and then click on it again and use the up and down arrows to get to the end, and then backspace to delete, and then I'll do Control V to paste. And we can probably change the font size there. It doesn't need to be that big. So highlight all of it, home, and let's try, I think 10 is good. And then for the title, we don't only want the Y value, we want Age of Miss America versus Murders by Steam, Hot Vapors, and Hot Objects. Okay, and then there we have our regression line is the dotted line. The equation of the regression line is right there. And there's the coefficient of determination, the R squared value. We're going to use Excel to get the correlation coefficient. I think I say that as well. Yeah, use Excel to calculate the correlation coefficient. So give it a label. And then we just start out with equals CORREL, parentheses. We highlight the X's, comma, highlight the Y's. And then the coefficient of determination is that squared, and hopefully it will match this. So just click on it and square it. Yep, 0.7571. And let's see what they said it was on the website. Oof. So you can see if it matches what it says on the website. For me, they said it was 87.01. And yep, that's what I got. 87.01. Okay, report the critical value of the correlation coefficient. And I think that was in the lecture notes. So 10.2 lecture notes. The last page of the 10.2 lecture notes gives that table. And I think I say 95 or 5% level of significance. So what was our sample size? For this problem, I had 11, right? Because I go down to row 12, but row 1 is the heading. So my sample size was 11. And at the 5% level of significance, I need my correlation coefficient to be at least 0.602 in order to claim there's a correlation between the two. So the critical value for R is 0.602. Okay. And state whether or not the regression line provides a good model for the relationship at the 5% level of significance. So I'm just going to move this up a little bit. Okay, so at the 5% level of significance, our regression line does, let's see the wording I used there, provide a good model for the relationship between the two variables. And that's because R is equal to 0.8701, and that's greater than the critical value of 0.602. 5A, answer the following questions. Okay, so this question, of course, relates to the graded one. So I'm going to have you use the regression line to predict the y value for a certain x value. So this graph goes up to 2009. So let's say in 2015, the winner was actually, let's just look that up. Okay, so it said in 2015, the winner from New York was, or the winner was from New York, and this says her age was 23. Okay, so in 2015, the age of Miss America was 23. Okay, so we're going to use the regression line. This says it's a good model, so we're going to use the regression line to predict the number of murders by steam, hot vapors, and hot objects in 2015. The first thing I'm going to do is give the equation of the regression line. I'm just going to type it here. So it's y equals 1.1147x minus 20.079. So the best predicted value for the number of murders by steam hot vapors and hot objects was, and then I want you to use an Excel formula to calculate it. So remember, the age of Miss America is the X, so I'm just plugging the 23 in for the X. So equals 1.1147 times, I don't know why I have the D32 there, 1.1147 times 23 minus 20.07. That would be murders. I mean, you can't have part of a murder, but that we just leave it as our that's our answer, predicted value. Okay, the next part, I believe I asked you to calculate a residual. Yeah, what is the residual? And so remember, the residual is equal to the actual value minus the predicted value. And so here, let's just say I pick the second to last point. So what's the residual? I tell you which point to use, but here I'll just say let's use the second to last. What's the residual for the point corresponding to the 19-year-old winner? Because I think there was only one that was 19. Yeah. Okay, and so when I say residual, it really refers to the y value, not the entire point. It just refers to the y value of the point. So when I say residual is actual minus predicted, those are both y values, the actual y minus the predicted y. So the actual value, the actual y value for the 19-year-old winner was 3, and that's murders. And then the predicted is what we get when we use the equation of the regression line. And so that is 1.1147 times, and here our x is 19, minus 20.079. And so the residual is actual minus predicted. And these are all the units are murders. And then the next question is, what is the best predicted value for the number of people who drowned, assuming the regression line is not a good model? Well, ours did happen to be a good model, but if the regression line did not meet that criteria where the R was greater than the critical value, so if the regression line was not a good model, the best predicted value is, the best predicted value for the number of murders is and I'm just going to say by steam, hot objects. Remember, so if the regression line isn't a good model, we can't depend on that. If we assume there's no relationship between the two variables, and I'm trying to predict the number of murders by steam or hot objects, then my best guess is to only focus on murders by steam and hot objects, not even look at Miss America. And my best guess, if I'm only looking at murders by steam and hot objects, is just to use the average of those values. So I'm just typing average and then highlighting the Y values. Okay, so about 4.54 murders. And you can change the number of decimal places. I really should probably use 1 decimal place. And these as well. Okay, and then let's see. Interpret the slope of the regression line in context of the problem. So for interpreting the slope, so when we interpret the slope, which in this case is 1.1147, we always think of that number as being over 1. So remember, slope is rise over run, and that's the rise, that goes with the Y values, and run goes with the X values. And we're always assuming that it's just this number over 1. So the X is always increasing by 1. So for a 1, and then for this problem, X is measured in years, so the increase would be in years. So a 1 year increase in the age of Miss America maybe I'll say for each 1 year increase in the age of Miss America, we would expect, and then now you have to just look at whether your slope is positive or negative. My slope is positive, so when X gets bigger, Y gets bigger. If your slope happens to be negative, when your X gets bigger, your Y gets smaller. So if it's positive slope, I'm going to expect an increase in the Y value, but if your slope were negative, you would expect a decrease in your Y value. So, and the increase is just whatever the number of the slope is. So we would expect an increase of 1.1147 murders by steam or hot objects. Okay. And that is it, I believe. Yep.